Okay, so this one, we're going to do a little factoring, okay? So here, number one, I have a different, not a different, I have a sum of perfect cubes because 2x to the power of 3 is a 8x cubed, and 3 to the power of 3 is 27. So I'm going to factor this, keep it the same, SOAP, okay, so that's my S, times, now remember to find these extra terms here, you're going to square the first, 4x squared, opposite of that, minus, to find the middle term, multiply these two, 6x, and then the last part is always positive, always adding, and then square the 3. And that is how you would factor the difference of perfect cubes. Sorry, not the difference, the sum. Okay, number two. Number two, you would factor out, so you've got to see, can I factor anything? And you can factor out an x. So an x is factored out, and this is 9x squared minus 25. Now, this is, don't get this confused, this is not a difference of perfect cubes, this is a difference of perfect squares, because 3x to the second power is 9x squared minus 5 to the second power is 25. So it's a difference of perfect squares, so you will take 3x plus 5 times 3x minus 5. And this was IM2 stuff, integrated math 2. Okay, we briefly touched upon this because this was heavily focused on integrated math 2, and you should know that when you have the difference of perfect squares, you can quickly write it like that. If not, perhaps maybe you could get yourself some practice problems on factoring the difference of perfect squares. Okay, number three. You're going to look for the greatest common factor. And the greatest common factor is, well, let's look at the numbers first. 2, 12, 54. So 2 goes into 2, 12, and 54. That's the greatest common factor for the coefficients. Now the variables. What's the largest, what variable with the highest degree can go into x to the fourth, x to the third, and x to the second? It's x to the second. So here you're left with x to the second plus 6x minus 27. So what you have to do here to take it one step further is you're going to have to play the x game. And then once you figure that out, you're going to be able to factor it. Okay, I'm not going to do that. You can do that. So you can press you can pause the video and then pick up where I leave off. All right, number 4. This one you're going to factor. Now, this has a leading coefficient of not 1, so this gets a little tricky. We're going to have to use the box method. But we can still do the x game. Top number is negative 30, 6 times 5, times negative 5, and the middle number is negative 7. So now, what two numbers can I multiply to get negative 30? But when I add, I get negative 7. So 15 and 2 is 30. That doesn't work. How about 15 and 2? How about 6 and 5? Does 6 and 5 work? Well, there's a difference of 1, so that doesn't work. But 10 and 3 works, right? Because negative 10 times 3 is negative 30, and negative 10 plus 3 is negative 7. So we're going to set up our box. So that first term is here, that last term is here, and you're going to take these two terms, it doesn't matter where you put them, they go here. So I'll stop there on that problem. You can figure out what goes on the what numbers go on the outside. okay? All right, number 5. Let's solve for x squared. So we're going to add 25, 16x squared is equal to 25. Divide both sides by 16. X squared is equal to 25 over 16. Take the square root of both sides, and x equals plus or minus 5 over 4. Okay, I went pretty quick. Like I said, this is when we covered this is pretty much an IM2 standard. So we did quickly go over these topics because you spent the majority of your time in integrated math 2 solving problems like these. So this was a quick little brush up of what you did last year. Number 6, you're going to factor out the x. So x is times x squared minus 3x minus 40 equals 0. Now, from there, you're going to play the x game. So what two numbers can you multiply to get negative 40 and you add to get negative 3? So you're going to find that combination and you're going to figure out that, oh yeah, you can write that as this in factored form. So it would be x. So a number is, so whatever you get here is going to go here. And then you're going to find the roots. You're going to have 3 roots, which makes sense because you're in third degree. So the first one will be 0 and the other 2 will, depends on what you get here. All right? All right, number 7 is a little tricky. And so my initial, how I would normally solve this is move the 125 over, and then you would take the cube root. But you would only be able to find one solution. There are other solutions because we're in the third degree, okay? There are 3 roots, and this is how we're going to find it. We're going to factor this perfect cube, the difference of perfect cubes. So I have x minus 5 times x squared minus, actually it's plus, same opposite, 5x plus 25 equals 0. Now, because this is equal to 0, we're in third degree. There's 3 roots. So if you solved it the different way, you would only get 1 root. Where are the other 2 roots? That's what we're finding. So when we set this equal to 0, this is x equals 5. That's your first root. And your other 2 roots is the solution to this quadratic. Now, you cannot factor this, so I'm actually going to walk you through the quadratic formula. So x equals negative b. So a is 1, b is 5, c is 25. So negative 5 plus or minus the square root of b squared, 25, minus 4 a c all over 2a, which is just 2. Negative 5 plus or minus the square root of 25 minus 4 times 25 is 100 all over 2. Negative 5 plus or minus the square root of negative 75 all over 2. So then we would take out the I, and then we would factor the 75, we would simplify the square root of 75. We would try to find a perfect square that goes evenly into 75. And square root of 75, you can rewrite that as the square root of 25 times the square root of 3, because 25 times 3 is 75. And the square root of 25 is just simply 5 all over 2. And this would be your other 2 roots. So this is your first root, and this is your other root. Okay? All right, last one, number 8. So let's see if we can factor it or use the quadratic formula. That's up to you. Either method would be okay. Let's use the quadratic formula. Let's practice using it. Okay, So x equals negative 18 plus or minus the square root of b squared. So let me use my calculator real quick. 18 times 18 is 324 minus 4 times 5 times negative 8 all over 2 times 5. So you would just kind of work through the arithmetic there and figure out what your two roots are. Okay, so the fifth video is going to show you what the answer key should look like. Okay, so don't only watch the fifth video if you're only going to watch the last video if you're really struggling, or maybe you're getting a lot of errors on formative and you're trying to figure out whether or not you typed it correct, even though you feel like you solved it correctly. Okay, so that's what the fifth video is about. It's essentially just the answers. All right, thank you for watching.